Hi, I'm Rich, and I'm here to give you a little bit of talk about XML schema definitions and how we use them to create kind of better XML. This is a topic that hadn't really been, I had a lot of trouble finding information on, but one particular book from O'Reilly which is shown here, is a particularly good one where I got a lot of information off of. So the motivation of this thing is that we want to create an XML file, right? We want to define an XML file in some way, but we need to kind of describe what's in it. So you can create XML programs that just have a bunch of tags in them without a plan, but that can cause lots of problems because suddenly every file is kind of different. And this is certainly useful in things like creating a configuration file or something like that. But for the most part, you probably want some sort of more formal description of what's going to be in there. And you can very quickly start to find different reasons that you may have to backtrack. So actually knowing how to describe an XML file may help you create a better XML file, even for simple examples, just by kind of opening your eyes to more capabilities. So this method kind of should be able to give us some sort of intuitive flexibility, some choices, lots of different things for us to give kind of rich content. And we should also want the ability to describe what happens if you break the rules. It should be fairly easy to verify when these things are there, and this process is actually called validation in XML terms. And it should be easy to parse by the computer. So the big question is, can we use XML to describe other XML? Yes, the answer is. And an XML schema is how that's done. So before we get started with that, what we'll do is just talk a little bit about XML terminology, right? The main elements, as a quick refresher, this isn't everything in there, but the terminology we're going to use in the description of a schema has to follow these XML kind of names. So the outermost thing, what we might think of in HTML as a tag, is known in XML as an element. And the elements in this example that I've got on the screen here are as follows, right? Let's highlight them a little bit. So these are the elements of the program. And they're just simply the tags. And what I've done is highlighted the names. I've only highlighted the opening tags, not the self-close and the self-closing tags. I'm not really worried about closing and everything. That's most of us have seen this kind of thing sort of before, so we'll skip right past that. But elements are your primary tool for that. All right. You can also have attributes, and attributes are sort of pieces of information within the element definition itself. And we use them for lots of little hints, mode changes, other things like that. In fact, one of the main ways that you can do good attributes is think of them as mode switches. Or think of an attribute as something that is about the element itself, not what's inside of it. For example, start time, in this case, has a unit attribute, a thing called units. And that's a description of the tag itself, not necessarily what's inside. That's not the only way we can do this, but it's one example. The other thing is that you might want to use attributes for is when it's a piece of information that must occur and it has no structure inside of it. So there's nothing more complex than that. These are always simple types. The other thing that's kind of your main piece of verbiage that's used all the time is known as content. And the content is the stuff inside of the tags. And so an example of that is everything in between the programmed, opening and closing program tags. So that includes those two events. And we'll talk about this example in just a second, by the way. Also everything within those tags, right? So inside of program has content, inside of event has content, and one of them, inside of the element called start time, has content within itself. So it goes 3 layers deep in that case. The other ones, the laser on, laser off ones, those don't have any content inside there. And that's important to know because we're going to describe each of these terms, elements, attributes, and content separately. There's going to be a little bit more terminology, but those are the big ideas, and it's the big terminology. Finally, we're just going to talk specifically about schema in this case for those who are not seeing this type of detail in other XML schema and namespace. So the schema itself is just simply the description of these tags and the ordering, right? That's all that we're going to do when we create an XSD file or an XML schema definition, is to make those, make this description. That collection of rules is effectively called the schema. And lastly, again, for the people who are doing, haven't seen more advanced XML, is a concept known as a namespace. And a namespace is given right here, right? So it has this prefix XML-NS, followed by a couple of letters of moniker, followed by some sort of text. The idea of a namespace, for those who have not seen it, is that you might be processing lots of kinds of XML at any one time, maybe with different schemas. Imagine if the word event had been used by someone else's schema. Now, how do you know which one to use and which one's not, especially when you're combining those maybe in the same overall schema? You might use parts of other schemas, as is often done in SOAP services and certain security services like the WS security and a lot of stuff. In fact, XSDs are a schema. They have a self-describing kind of schema to them. So what we want to do is add this little prefix that separates out one person's schema from another's. The good news is this three-letter thing, EX, right here, is essentially up to the person using it, not to the schema designer. We give this website, that's the most common way, is to associate your schema with a web page that you own, because no one else can do that. But actually what's inside there is just random text. You just simply want something that's kind of intuitive, that you own, that someone else making a different schema that might use the word event would not have that, because maybe that's part of not mysite.com, but yoursite.com, whatever. So using your website is kind of a nice way, but actually what's inside there is not a lookup. It's sometimes used in tools by that, but for the most part it's not anything important. But the 2-digit code is up to whoever's using it. So in this case we're going to use EX, and you notice EX, for example, shows up in all these different prefixes with a colon in front. So it separates out my namespace from that is EX from mysite.com from someone else who might want to use these same definitions. And so now we can use them in the same thing. This is good news, because it's going to turn out that XSD definitions will use words that you might want to use, like element and attribute and so on, like that. So they use their prefix and you use yours, and anybody can now use the word element or attribute as long as they've got different prefixes. So here's our example that we want to build. Right, we're just going to describe a couple of laser pulses turning on and off, and this is kind of an oscilloscope looking view where I have two lasers, a helium neon laser and a titanium sapphire laser, and one turns on and then back off, and the other one turns on and stays on. And so this is kind of part of a project that I'm working on right now that has this kind of description. So what we've done is we've created an example program. And it starts out, our overall thing is just called program, that holds everything. And inside, we're going to slice up time into these things called events. And so you can see this event right here happens at 5 microseconds, and it turns on. Okay. And what happens inside that event is laser Heaney and TISAF both turn on. They have this element called laser on. And this is the action. So laser on is assumed to be something that has some meaning. And then a channel, because maybe you can turn on lots of different lasers. So here's two lasers. This is the laser on for helium neon. This is laser off. And so here's the laser on for Heaney. Here's the laser on for TISAF. So boom, there it is. Then some other time later, 15 milliseconds, only one of them turns off. So cool. and that's good news for us and stuff. So the events kind of correspond to the time, and the laser on, laser off correspond to actions, and within those we have a description of what this is, right? And you can see the larger version right here of the program with a namespace and it's used that way. Okay. So let's start describing this grammar. What we've done, I've just taken the simpler version here without all the garbage and the prefixes for namespace. But remember, namespaces are very important, and so we will use them. So this is just to kind of clean up the screen. So our rules from that file here are as follows. I'm just going to go element by element and come up with the rules that as I see them or as I intended them. A program contains one or more events. That's it. An event must contain a start time. Okay. May contain, may, so it's not required, may contain a laser on or laser off. Start time has to be the first element. I've just decided that rule. You could imagine that that's not a rule, but I'm going to make it one. That has to be the first element. Start time can only occur once, and that would make sense in our laser thing. We don't want events to have multiple start times because those would be different events in my kind of conceptual model of this laser thing. So it can only occur once. Laser on and laser off may occur one or more times. Why? Because we're allowed to control multiple channels, multiple different kinds of lasers. So you can imagine laser on and laser off maybe happening more than once, and as is done in that first one. And laser on or laser off may occur in any order. That means I don't have to bring all the laser ons first. I could put laser ons followed by laser off, on, off, on, off, on, off, on, off. As long as they're after start time, no problem. Okay, so that's the first part. And remember, this is the grammar, right? We're trying to describe what we want out of this. This is a very well-known formal part of computer science in the design of languages, is creating a grammar. So there's lots of different names for it, and one of them is called a Brachis-Nauer. And even XSDs, XML schema files, as we're describing here, are actually a formal grammar. They have a lot of interesting rules. So we're going to formalize this definition. Start time is an element, right? It contains a number in the form of text. So inside the content, the thing in between these, has a number 5, which is the form of text, but it's only a number. It's only ever going to be a number. Start time has no child elements, so there's no tags or elements inside of there. Remember, this is gets into what's inside these things. And it must have an attribute that we called units. And those units might be the word US for microseconds or MS for milliseconds. Okay, cool. And that's all the rules for start time. Laser on, one of our actions, has no content inside of it at all, right? You can see it's a self-closing element, self-closing tag. And it must have an attribute called channel. So there's channel, it's required to be in there, and the channel may be any free-form text. Obviously, you could make that a different rule, but that's the rule that I'm going to say. I'm allowed to put it in anything. Maybe if I gave a name of a channel that didn't exist, maybe the program may kick it back later. But it's not an illegal piece of XML to have a channel definition that was not defined. So that's an interesting thing to know about this stuff, is when you're creating these things, you may give yourself rules that are not as restrictive as it could be, but you're saying some downstream program is going to do that. It's not important to change the definition of XML just because we want to add these later. Now that shows into an interesting rule about how restrictive I was with this units attributes, because I said I'm only going to support microseconds and milliseconds, right? So this might be something that it's so well known ahead of time that I could have seconds and milliseconds and microseconds and nanoseconds and picoseconds and kiloseconds and centiseconds and megaseconds, stuff like that, or even minutes or hours or whatever, that maybe I do articulate this list fully. But the fact that I did fully articulate this means that if I change to add another one, I have to change the definition of the XML. And so we're playing a little bit of a, kind of a practical game to say, I know I'm never going to use any more of this because changing the language is a big deal, But here we might change the names of these more rapidly, and we don't want to publish new schemas, right? Okay. And last but not least, laser off is identical to laser on in every way except for the element's name. So anything you can do with laser on, you can do with laser off. It's just a different word. Everything else is the same. The attributes are the same. The lack of content is the same. Everything else is the same. And this is going to be an interesting, this is why I like this example. It shows off almost all the cool features of an XSD description. So let's take some observations about this. Taking that textual grammar description, what we've realized is that every element has a name, obviously, right? A program is one element, elements another, or events another element, and so on. And then inside, all the time, we're talking about the content in terms of does it repeat or not? Does it have child elements, and what are they? And what's the ordering? These three pieces of information help us to describe the structure. Similarly, we are always talking about elements having 0 or more attributes, right? Program had no attributes, but an event had no attributes, but start time did. So the name of those attributes, the allowable values, and any sort of rules. And lastly, we wouldn't be much of a good grammar if we didn't have some ability to reuse things or group things. So this is starting to map out into kind of a style of describing an XML thing, or really any grammar, right? If you're a computer science person, you might be noticing some things about how you might describe this in a regular expression or not, especially the repetition and the ordering portions of it. So XSD has a very specific kind of way of describing that, and we'll see that here in just a second. So let's talk about XSD, the XML Schema Definition. This is an international standard. You can download it off the internet. And the file names usually end with the word XSD, and the prefix that's often used is XS. The XSD is not your XML file. I mean, it is, you define the XSD, but you don't have to wrap this into every time you want to use a schema. It's a separate file that you will then attach later on. In a similar way to how a lot of things are done, you can import a namespace and just use all of that stuff. But the point is, the program that uses your XML file will also have to need, kind of on the side, as a side channel, need to be given this definition. So it's a separate file. Once you've defined the grammar, once you've done the XSD, you kind of attach it to any user programs as a separate file, and now any new things you'll validate or you'll process against that XSD file. Okay? There are two versions of the specification, version 1.0 and version 1.1, and those are current at least as of the time that I'm making this video. Now, what's in the XSD is it's two things. It's actually a text document, and it's also an XSD file itself. So it's a little bit of a chicken and the egg, because version 1.0 describes version 1.0 in XSD version 1.0, and 1.1 does the same thing. It describes itself only in its new thing. So any processing may have to work with a lot of strange rules. I generally use XSD 1.0 because the tool that I use for validating stuff, xmllint, which we'll see in the end of this, is set up for this particular grammar. And that's about it, right? So XSDs define the rules and the tags used to describe this grammar, the elements used to describe this grammar. And they're described in the form of these tags that represent, again, the same thing that we saw in our observations: ordering, repetitions, subclasses, and several other things. So the parts of an XSD file are as follows. You will define elements. You will define attributes. These are actual tags inside of an XSD file. Elements. You define the attributes. You define what we call types, which is sort of a it allows us to do a lot of reuse and expansion and stuff like that. So you can start out with kind of like an object-oriented sort of view. You can start out with sort of a basic type that all things might have to do, and then extend it or restrict it later on. For example, there are simple types like numeric, and string, and date, which is obviously a date is a restriction of string. You might have a further restriction that says, okay, this is a simple type, but it's only positive numbers. So you would take the simple type of double, which is a floating. All the numbers are double. There's no real. There might be an integer one. I have to look. Double and say only double where the value is greater than or equal to 0.0. Yeah. Or you can have types that are complex type, which collect together elements inside of it. So a simple type is just going to be content, right? It's just going to be, just going to be a basic computer science kind of programming sort of type. It's either string, double. There's a couple. There's very few of these. Most of the time, you're going to work with these complex types, and these can aggregate, extend, restrict, collect multiple copies of with different names of simple type. So the type is sort of like your object and object-oriented. The content is, again, about what's in between the opening and closing tags of an XML file, or of an XML kind of statement. And the content is where we're going to spend a lot of time talking about what's inside of another tag, right? Like program contains element, element contains start time and laser on, laser off, and so on like that. So content is where we spend a lot of time. And again, there's a simple area. Simple contents and simple types, by the way, can't be reduced any further, but they can be restricted. They just have no parents, right? They're base classes, if you want to think of it that way. So simple content has a single rule and no real aggregation. And complex content can have lots and lots of different things. So again, most of the time we're going to talk about complex content and complex types. Okay, so armed with this kind of broad overview of some of the terminology of an XSD file, let's match up the description to our schema. So remember, we had in this file, we had made some observations, right? After all of our rules, every element has name, content, blah, blah, blah. And over here, what I've done is I've shown you kind of what to expect in the XSD file in terms of that. I remember I said an XML file or an XSD is described using tags. And we're going to use the prefix XS for everything that the XSD namespace provides. So we're going to match up each one of these. And you notice that each element has, from our observations, has an element, right? So we have an element tag that defines in the XSD file. It defines this begins the description of an element. And every element has a name, which means that there is a tag called @name. And if you've done XML processing before, like using XSLT or schematrons or something like that, you might be familiar with the concept of an XPath, which is an XML path. I'm probably going to make a video about those things because they're really interesting. And I've never quite liked some of the descriptions that are out there. It's a hard learning curve. But an @ symbol is usually used to refer to an attribute, @ for attribute, whatever. So it's not an important thing, but you will see a name attribute to describe the element's name. Remember, XS element simply says start a new element. The name attribute inside of that will say the name of the element that you're trying to describe, right? So remember, XSD has its own language, and so you create XS : elements to describe the elements of your XML. Okay? So remember, we talked a lot about content, right? And so we have, as I mentioned before, we have two different types of content: simple content and complex content. So the description of the content will be wrapped inside of these two XSD tags: simple content and complex content. The child elements that are within any element, right? So the children of that will be described by having XS elements inside of this kind of top level one. Now, ordering will be a very important topic, and one of the most important things to remember about a schema is deciding the order of your elements. So we're talking about the children of some top level thing like program contains elements, right? And what we're going to do is set up an overall ordering style. And there are three options for you, right? XS any means that I'm going to describe child elements and they can appear in any order at all. Whatever. Doesn't matter. XS sequence mean they must appear in the specific order in which I will tell you. Any misordering is an error. It will not validate. That's an invalid XML file according to the schema, right? It's not a valid one. And XS choice means pick one, but not anymore. So you might imagine saying turn on, turn off. We didn't do that in our example, but you can't have turn on and a turn off. So you're allowed to put on, you're allowed to put off, you're not allowed to put both. So that means a choice is in order. Okay? Now, as you build these things up, you'll find that that you kind of wrap these basic concepts in and of each other, and you put up things so that you can have sections that are in any order and other sections that must be in a specific order, and they all turn into the same basic parent-child relationship. But for right now, these are the basic tools. I'm going to describe a sequence. I'm going to describe a set of children that can happen in any order. I'm going to describe one that must occur in my order as I've described, and this kind of, then here's children that must be in this mutual exclusive kind of thing. And lastly, repetition was an important part of the content, right? So we have repetition rules that say minimum occurs and maximum occurs. And one way of saying an optional component is to say the minimum occurs is 0. So you can have 0 or more of this. If you're a regular expression person, it would be the star operator, right? This element star means I can happen 0 times or more than that. So the minimum occurrence is specified. You might say there must be at least 2 of these, for example. If you're building an algebra, the division must have exactly 2. It can't have 1. You can't divide 1 number. You have to divide 2 numbers. You also can't divide 3 numbers. You have to divide only 2. That's how division works. So the min and max occurs tell you the repetition of that particular element. Okay? We have similar rules for attribute. There's a definition that at the top level it says XS attributes, right? And so we can define inside there the attribute has to have a name. That's a required field. The type, is this something that's going to be string? Is it going to be something that's a restricted string, like it can only be 1 or 2 different strings, like microsecond or millisecond, and that's it, and so on. And then also whether the entire attribute is required or optional. And like any good thing, we would like to have, right? We mentioned that we want to be able to reuse things. So the good news is we can take and wrap these things into a type, which is kind of this collection of all sorts of stuff, and give it a name. And then we can reference that type by its name. And so you can create that type of thing. And lastly, grouping is used. And grouping is used to build these basic, kind of aggregators here, any, sequence, and choice. Group them all together, and then you can start to build in richer structure. You have to have this one first, then you can have 2 or 3 of this one, then you can have these guys in any order, and then they can be followed by, these in the specific order, and you can do that. So grouping is used quite often to build these types of things sort of together. Now let's go ahead and define an XSD file. And what we're going to do is we're going to use a tool called Oxygen. And it's a commercial tool, but I really, really like it. And I don't get paid for it. There's no compensation for it. I just simply like it because it has this kind of like IntelliSense sort of thing that you get from like Visual Studio. And it's really quite rich in terms of integrating with other tools. So enough of the sales pitch with that. I don't care if you use it or not, but I'm going to use it to describe this kind of thing because its templates make it easier. So let's give this thing a whirl. Okay, so here we are inside of our Oxygen program. And we're going to start with just having, as you can see, the original program without the namespace attached to it, just so that we have that kind of to look at on the side as we begin typing this. And just like any other thing where you watch someone type, I would probably make lots of typos and mistakes and everything like that. Heck, I even saw one earlier that we'll probably have to edit out. So, okay, but to begin a project, right, what we're going to do is just, and again, this is not a tutorial on how to use Oxygen. It just helps to use the template. So I'm just going to start a new schema, XML Schema 1.0, and it will create a template file, and it gives you this kind of graphical thing, right? This is dumb. I don't really like this feature at all. We're going to stick with the text. Zoom in a little bit, and you can see it gave us a very, very basic outline here. And so what I'm going to do is just dock this over to the side so we have it kind of side by side. All right. Okay. So to build your XML schema, first of all, the file is going to be called XSD. We have the usual XML decorator, the XML version, which is different from the schema version. And the schema is really defined by this particular URL, the w3.org site with the 2001 XML schema. This is a schema between 1.0 and 1.1, but we're not really going to use any of this kind of stuff. The point is, what we're going to do is build a new schema, and so we need this to start, right? So this schema has a root tag called xs.schema, and everything we do is going to be put inside of that, right? Now, one thing that we're going to have to establish is another namespace. Remember, we talked about the importance of namespaces. And it's important to actually begin your first XSD with your own namespace. Remember, the rules of namespace is that you have this 2-digit leader, prefix, that's going to represent this whole thing so that it's shorter. But anybody is allowed to pick a different one and refer to the same URL, and it will be the same namespace. So I don't have to call it XS. I could call it XS2. I could call it schema. I could call it anything that I want. We have to do that for our own definition. So every time we create a custom element, we need to put it in a namespace to separate it out from what this thing defines, right? Remember, this is defining some tags. We're going to define some more elements, and that means that we're going to have some confusion if we don't start out with a namespace, right? So to do that, to do our schema, we're going to build what we call a target namespace. And that means that this is the namespace I'm going to use for everything I define here to separate it out. It's another attribute of the top level schema thing because it's going to kind of apply globally. And we have, the nice thing about Oxygen, this IntelliSense thing, all I got to do is hit the space bar and it tells me what I want to do, right? So remember, my target namespace in my example was, I think, http mysite.com schema xsd. Okay. By the way, just so you know, HTTP and HTTPS, these are different namespaces now. One letter of difference, one change in capitalization is all it takes to do that. Okay. So we've created a target namespace. And that target namespace is going to be, this is essentially the namespace we're defining, right? And we're going to add that same namespace to give it its own prefix. We're going to use this prefix a lot. So we're going to use that same thing again, using the standard XML namespace, and we're going to call it EX. All right, now what we did here is we're saying this namespace EX exists, and we're going to use it throughout this thing. But over here, target namespace is the same thing. This is what we're defining, and this is a this is actually a schema definition, right? This is just for the schema. But over here, this is all XML follows these rules. So they didn't rebuild those things again. And there's an implied in the validators. There's an implied if this target namespace is equal to any of the namespace prefixes, then it's going to be used regularly. So it kind of makes sense, but that one's a little bit of a hokey rule. Lastly, we're going to require that we only ever define things in this namespace, right? So this is another rule called attribute form default, and we will only use qualified names. So that means names with the namespace, right? That's it. If there's a missing namespace, it's not optional. You have to use it. If it's not, then, you know, that's not part of it. You must be referring to something else, okay? So these are just my standard things that I do. All right. Into the good stuff. Now, we want to begin by defining our program element. So let's do that. XS elements, and again, this is why I love Oxygen, right? It finishes stuff for me. It actually told me what all of my choices were. It says, by the way, you know, you're allowed to put an element, you're allowed to put an annotation attribute, you know, anything you want. And we're going to start with program. Okay. Now what this means is I call it program, but anytime I refer to it, I'm going to have to refer to it as EX:program. So just remember that. And it's got some structure underneath it, and we're going to get to that in just a second. Okay. But for right now, let's just fill in all of our blanks, right? XS start time. Okay. Helps you out, closes things out. And we're gonna make we're gonna do something weird for laser on, laser off here for a second. But let's start with the first thing, right? We said that programs contain events. So that means we have to start by creating a complex type, because we're saying that what we have here is going to have some further substructure underneath it, right? And that inside of that is going to be, what order do we want? Do we want it in all, any, choice, whatever? What would we like, right? So again, here's the rules, right? And so we're going to say all, because it doesn't matter. We have only one type in here, so the ordering does not actually matter, right? So this type has, so remember, type followed by an aggregation, right? The ordering rules, and then an element. Okay. Now we could have defined start type right here. Okay. No problem. It's allowed, perfectly allowed. But start time is going to have a lot of content in it. And so what I'm going to do is I'm going to defer it to down here. So instead of name, we're going to use a ref. And the refs available are, we could use program itself, right? It could be self-referential, which would be kind of recursive, or we can use start time, because that's the only one we've defined, right? And so what we're going to do, I screwed up here. This should have been called element, or event, right? There we go. So now, when we do this again, let's use our IntelliSense. Event, okay? Now, I don't really need to define anything else, so we're just going to make this a self-closing. But now let's talk. So we've talked about the element. We've talked about the ordering rules, right? For program. The fact that we've said program contains event. We haven't said anything about what event is. That's down here. But we have said the ordering of what's about to follow. And that's saying use all of them, right? We could have done any of them. And now let's talk about the multiplicity, or the repetition. And so we've said min occurs and max occurs, right? The minimum number of things in a program would be 0. We could have a stupid program. There's no real, it wouldn't break anything to have an empty program. And for computer science people, you start to realize there's a lot of merit to sometimes handling the empty case, because it allows you to not have to make side things of what to do when this is, you know, empty, that kind of things. And the max occurs, okay, is this thing that we're going to actually call unbounded. Okay, so what we just said is there's no limit to this by the rules. Now, practically, your programming, your consumer of these XMLs may actually say, no, it's limited to 20,000 or something like that. That's okay. But generally, unbounded simply just means that it's not part of the grammar that would be a runtime thing. The consuming program decides when to kick it back on its own. But it's not any illegal sequence of stuff. Generally, unbounded stuff, if you do anything with WS security, unbounded is a bad thing to sort of have. But, you know, because you can have buffer overflow. So generally, you want to do that. But we're going to keep this a simple example. This program is allowed to have 0 to an infinite number of events. And that's it. That's all there is to program. Now, like any good documentation, like any good programming effort, we should probably put some documentation. So that's another element within element that is called annotation, which is a group of things that are basically not part of the schema, but they're just side information, and comments would be one of them. And then XS documentation. Okay, that's about it. So we've just said programs contain an unlimited number of events, including 0. Now we have a problem here. So somebody is not happy about something. So again, oxygen to the rescue. What is your error? Okay. So what it's saying is the aggregation group for all can't be unbounded. So that's probably a rule that has some semantic meaning. So let's change it to one of the other aggregation types. How about a sequence? Sequences are allowed. So a sequence can be unbounded, right? So exactly why usually the w3.org text description of something will have some rationale behind that. So we could look that up, but I don't care. Okay, so we are done with program elements, right? All right, now let's talk about our next one down, which was event. So what's part of event? Well, it's almost always gonna be a complex type, right? Because it's not just simple textual content and stuff like that. So let's begin. So we know it's got a complex type. We know it's going to have probably, well, we've defined that we said that rule that start time must be the first one. So that implies a sequence, right? So sequence, great. Things must be in this order. And the first thing we're going to do is we're going to say an XS start element, which is going to be called start time. So we haven't defined a start time yet, so let's go ahead and do that. Element whose name is start time. And voila, now it will start, it will exist over here. And it's going to be a ref because we're not defining it in line. So here's start time for us. Okay. Now, other rules that we had were that it could only occur exactly once, right? So min occurs equals 1, max occurs equals 1. This is telling us that if you count these things and you only get 1, then you're good. If you count them and get less than 1 or more than 1, then you are in illegal XML. So great. What else is in there? Well, we're gonna look again at one of our other observation rules. Remember that we had that rule that said the laser on and laser off were exactly the same, except they changed names, right? They had all the same fields and everything like that. This is a good example where we might want to create a set type. So we'll get to that. We'll get to start time here in just a second. But first thing I'm going to do is I'm going to create a type. Remember, we were doing complex types in line, but actually I can give them names and then reuse them. So let's go ahead and do that. This is going to be XS complex type, and it's got to have a name, right? So we're going to call it actions. Okay. And like anything else good, right? We're going to go ahead and put some documentation in there. It is a little bit of a pain that you have to do documentation inside of an annotation, but I've actually used some of the other annotation features for cool stuff before. So anyway. needed. This is the basic definitions for for laser on, laser off, and yeah. Okay, so what was common about laser on and laser off? Right. Well, we know that it was it had no content, but it did have a an attribute, right? So let's define an attribute. And what did they have? They had a thing, and the name of that was called channel, right? And we said, by the way, here we're going to close that because there's nothing else inside of attribute. And we're going to say, well, we also knew that the channel was going to be text, freeform text. So we can actually take and we can use another one of these things, which is the type. And the type is, you know, again, the attributes of the attribute definition will tell you the type of the attribute. It's a little circular because you're using XSD terminology to define itself. So there's a little bit of, sometimes you can get lost in, you know, okay, it's an attribute. Is it an attribute of something, the schema definition, or is it something of what I'm trying to say? I'm trying to define an attribute called channel, whose capitalization was wrong, by the way. And now I'm going to say this is a string, right? So you can see I have lots of different primitive types, right? But what I'm saying is this is allowed to have nothing else in there. Okay? And by the way, if I really wanted to be crazy, I could have pulled attribute out, given it a name, done a reference and everything like that so that I have documentation for this, right? But I'll just group it together. It has a So there we go. One last piece. Remember I said that the channel was required. So we have a thing called use. Use is required. The prohibited one is kind of a way to later on in the game say, by the way, I'm disabling a feature. It's not really well used. You know, if you want, you can look at the O'Reilly book that has that. There's quite a good definition or description of what that is. But for our purpose, we've just said that there's this type called actions, and we're going to use that later on, right? We're going to kind of, we're abstracting this away to say, here's all actions have a channel, okay? So now, now that I have this actions, what do I do with it? I've never used the word laser on and laser off, and we know that those are our two actions that we want to support. Because they share the same basic structure, they're both going to be that way. So let's try it one way and see how it doesn't work. We're just going to define them as elements. Okay, one will be called laser on, and its type is now going to be actions, because remember we defined a complex type right up here. Okay. All right, so this is cool. This is very simple. I'm going to skip the documentation for just a second, and this one's going to be called laser off, whose type is also actions. Okay, cool. I've just defined laser on and laser off, and they are of this, which means whenever I see laser on, it's going to look and see what's an action. An action has no content, and it has this attribute that's string type called channel. So that's cool, right? Everything's looking good so far. Back up to our event definition for a second. Let's put it to action. Okay, now this is a sequence, so I could, you might think, laser off. Let's see, laser on. Okay, no problem. And I can have there's an implied min occurs and max occurs. If you don't put in min and max occurs, they're going to default to 1. So actually, this is a little redundant, but I put it there to be explicit. But here we're going to say min occurs equals 0, max occurs equals unbounded. Oops. Unbounded. Okay. So cool. And then again, right? And maybe you're seeing the problem already. Okay. The problem that we have is because this is a sequence, these must occur in this order. Now, min occurs equals 0 means that I don't have to put on laser ons. And min occurs equals unbounded means I can have an infinite number of them. And, you know, same thing with laser off. But because I put them in laser on followed by laser off, that means I have to group all the laser ons before I do the laser offs. That's not good. That's not what we wanted. Our rule was we could put them in any order we want. So a new tool is required. And we're going to use what's called a group, right? So we're going to basically say, let's treat laser on, laser off as if they were one thing, rather than here's all the laser ons followed by the laser offs. I'm going to group them together with a single name and then say that group can happen must happen in the sequence. Okay, so a group is fairly simple. XS group. We give it a name. The name will be called, I don't know, laser action. I just wanted to differentiate it from that other thing. Maybe I should have called those things action types, but whatever. And we'll call it laser stuff. Okay. Okay. Now what's inside there? What's inside there is because it's a group, it now can have either the sequence or the alls. You can't do a choice with a group because of how it would interact with multiple different things. But for right now, we're going to say it's a sequence, or I'm sorry, we're going to say it's a all. Okay. And remember that note that popped up when I said that, that was a that note that popped up when Oxygen gave the hint told us that every element could happen 0 or 1 time, right? And that's okay, no problem. So let's do that, right? We're just going to say an element, a reference is a laser on. I could be more specific and actually have repetition times, but honestly, it's either one, right? So we're just going to say min occurs equals 0. 0. Okay. So this should be pretty good. We'll find out as we bounce it off the compiler and stuff like that. But now we have this group, right? And we're saying, called it laser stuff, and now I can go back and treat this the way that I wanted to up here, which is it's an XS group reference, and there's only one group, right? And the min occurs is 0, and the max occurs is unbounded. Okay. So now what it's saying is the sequence. Oh, it's got a problem. We're going to find out what that is here in a second. I think it hates this. I might have to go back to my notes. Let's see if that solved it. That might be I might need to use a sequence. Did that solve it? It did solve it. Good. So now I'm going to put this back in, right? What it's saying is that it's optionally, could be this, or you can move to the next one. Again, this is one of the more functified things about working with XSD files, right? Is that, oops, sorry, min occurs. Is kind of all these rules, and they do actually have a lot of rules, they make sense in the larger kind of analysis of the grammar and stuff like that. You can have conflicting rules, so they're trying to avoid that. But anyway, so we've created our laser stuff. It's basically saying it's either this or this, right? I think we could even have done a choice here, maybe. Yeah, a choice would have been easier. Let's stick with a choice, right? Because choices means I'm going to only pick one of these. This is what I wanted, so that's a better thing. Okay, laser stuff is one of these two, but not both. And we're saying now the group of laser stuff can happen in any order. So the first one could be on or off. The second one could be on or off. The third one could be on or off, right? So it's kind of, that's the way it's sort of describing. Perfect. So we've got our events down. Let's tackle start time, the last element that we basically have. So again, complex content, complex type. And we're going to say that there's no further structure on, or there is structure on there, but that complex content is going to be a string. Sorry, a double. I think I said a double, and we're allowed to put in here. It is going to be a complex type, right? Because it has attributes. Okay, so we have one attribute. That attribute is going to be called. We're going to give it a name. We're not going to do it inline. I'm going to define a more complicated attribute here. The rule for start time was that the units were called. We'll give it a name. Okay, and we said it was, but we'll just jump ahead and we'll say that this was required. Okay, all right. Now, let's make a type for this, because remember we said that the rule was it could be US or MS, right? That was our main thing. Sorry, not attribute. XS type, simple type. It should be. Yeah, here it is. Set of constraints on strings and information that they do in code and everything. After checking my notes, this is a simple type because it derives from, it derives from only the simple type. There's no other structure in there. It's just a restriction of something that already exists. So the name of this is going to be time units. Okay. And the way that we're going to build this is, let's go ahead and just put the annotation in here because this requires some explaining. This is a restriction on strings so that only US and MS are allowed. Okay, that's it. All right, now you notice that simple type isn't happy because I haven't filled in all the information. This is, again, a restriction. The base type is going to be XML XS string. So it's a restriction on strings. And it's saying that there is an enumeration here, right? For programmers, right? Enums are text names associated with kind of like numbers. There's no real numbers associated, which is to say they don't have an ordinal value, but they do have a text value, and they're allowed or they're not, right? So the first one we have was US, okay? And the second one was MS. You can imagine us adding more stuff, okay? Now, what did we do here? We created a type, not a content, right? So this is saying this is what's allowed inside the quotation marks of this particular attribute is a type, because there can't be any complex stuff inside there. It is a simple type, and it's a restriction of the basic string so that only these are allowed. That's it. That's all that we're doing with this. It's only one of these two. This is a lot like a choice if it were elements, but it's not. It's strings, so it's not quite the same thing, but similar ideas. Okay, so restricting strings, and you can do lots of stuff with restrictions. You can put regular expressions in there and all sorts of other cool stuff. You can look at that. Okay, so back to this thing here. He's unhappy. Why? He's unhappy because we'll get to that unhappiness in just a second. Okay. So we've given ourselves our units attribute, and so now it's time for us to add the type to it. EX time units. Whoa, come on. Okay. So this is saying that the units attribute can only be in this restricted set. That's the only types of string that are allowed, right? The type of units is string, but it's restricted to just these two. So we've just done that, and then we've said it's required. Now, the last thing here, I screwed this up when I did this. Okay, so what we want is a simple content, right? And so pause for a second here. All right. After checking with our notes, the way to describe the fact that start time has text inside of it, in its content, is to, again, restrict this into a simple content. Okay. Why is it simple? It's because it's only one of the base classes. So it only contains a string. It only contains a double. It only contains a this. It only contains a that. Okay? But it doesn't contain any elements inside of it. So it does have stuff inside of it, but it's only elements, right? And so we're saying it's simple content. And because these are numbers, right, we want it to be, we want the number to be an extension of double that has this attribute inside. So I've got my stuff kind of in a strange order. Okay, let's think about what that was, right? When we have a thing like program, the content of program is these events. And anytime you have an element within an element, that's considered a complex content. Okay, the content being what's between this and this. So that includes the two events. Okay? A simple content means that it is like this, right? Between start time and open and close is a simpler one of our known base classes, which was double in this case. But we had to extend it because it's not that it's just a tag with a 5 inside of it. It's a tag with an attribute that has a 5. Because of that, we have to extend the basic class of doubles to be tags with doubles that have this attribute. And that makes it complex, or that makes it an extension of simple content, but not complex content because there's no tags inside there. A little confusing. This takes a lot of Stack Exchange searches and a bunch of other stuff like that. But we finally got through it, right? So this should basically give us what we want. And so we have a situation now that we have, you know, got everything kind of put together, and this should have all of the tags. Let's double check it. All right, we have a program. Programs contain 0 or more events. That's it. Events contain a sequence of start time, exactly one start time, followed by this group of laser on, laser off, laser on, laser off. Start times contain a double inside of the tag, and it's been extended to allow this tag called units, which was an extension of the string class. So it's this type of time units. Okay. Time units had, you know, these two selections, and actions defined everything that was going to go on inside of laser on, laser off, and the group called laser stuff said, by the way, this group is this. So conceptually, grouping and typing are different because you can have a type that may not be part of the same group. And so you kind of got these two dimensions of stuff that you can actually put tags that have the same type in different groups and stuff, and then you can repeat the groups and so on. So that's it. Here's our full thing, zoomed out, and that's the end of our schema definition. We'll save it, give it a name, which is, you know, mysite.xsd, and it lives out there. Okay. Now let's take a break, and the next thing we're going to talk about is how to validate a program such as this one, an XML file, against this schema. Okay, so that'll be our next thing. Okay, if you recall, the last time we actually set this up so that we created this schema, this XSD file, and we've got all the rules put in there. And now let's see if it works. Now this is going to be a little bit about cool stuff you can do with Oxygen. But it helps to show how the documentation kind of gets put together and stuff like that, and how you can kind of use this tool. We're going to then go into a program called xmllint, which will be used to in a more standard way of sort of validating a schema, right? So we have this schema, and again, this is very Oxygen centric, but let's just go ahead and create a new file. That new file is going to be an XML document. Create it, and we're going to first thing we're going to do is create a validation scenario. And remember, validation is checking a XML file against the schema to see if the tags follow the rules that you've done, right? So we'll go ahead and make a new rule, and we're going to add a cancel, remove. We're going to validate it against a schema. And the schema is going to be, we'll just open this file, this one called my site that I created just now. Okay, so schematron is kind of a whole other thing by itself, so I wouldn't really too much worry about that. Okay, so this is just saying I'm going to validate this against your schema. And there's a couple of different engines, right? You can use Saxon and Microsoft XML, libxml, and a few other things. Xerxes is an open source one. So there's lots of validators, and it's just basically saying which one would you like to use. And I think they use Saxon as the main one, which is an Apache project, as I recall. So anyway, okay. So this is just a validation scenario, and we're gonna let's give it a better name than Untitled 3, which is. All right, cool. Apply it. Great. So, okay. So we started out with our program tag, and we're going to go ahead and add a namespace to this, right? Which was called EX. And so now this is part of EX. Okay. Cool. And you notice what it's doing is it's actually kind of validating as we go. So down here at the bottom, it's saying validation successful. And it'll help us with this IntelliSense looking thing. Remember, our first rule was we could have events. Okay? And it helped us out by doing that. But what it didn't do was give us the units, right? So it knew we had to have units, but we didn't say which. So we're going to say we're rebuilding our original thing, which was 5 microseconds was the first thing. Then we had our 2 events. Laser on. The channel was the Heaney laser. And we also turned on the laser for the TISAF. I think I called it that. Okay, so that's our first event. Cool. What's allowed next? Well, let's see. Oh, look, just events, right? And it's angry, right? It's giving us the orange thing because we haven't defined what it is. So in milliseconds, 15, I think I said it was, something like that. We turn off the Heaney laser. Okay. So this is helping us out, right? It's just basically saying what the schema did in this validation scenario. So let's Oxygen sort of help you with this IntelliSense thing because you have described what to expect next. It was able to fill in those blanks, right? So we can run a validator and just see if it's happy. And look, it is successful, right? Down at the bottom. No problem. Now let's throw in an error and say something else, right? We're going to change the ordering of the start time. Now it's angry right away because it said invalid content was found. It's a little hard to see. We'll try to zoom that in. But one of start time is expected. One of, because it was originally defined as a sequence, right? And start time, right? It's saying, hey, here's the fully qualified name, right? Everything represented by EX is this mysite.com/schema, and start time. Okay, so you're saying I want to have a start time right here, not a laser off, and that was true. We required that to actually happen. Okay. So the validator though failed because we violated one of the rules, right? And the rule said start time had to be there. Okay. Now, nothing said that I can't have a million laser offs. In fact, they're even the same one. There's no rule that says in the language I can't turn off the Heaney laser a million times in a row. Or I could turn it on and off in different events. It's allowed. And nothing even says that the word impossible laser was a part of it. If we wanted to, we could have made a channel an enumerated group just like we did with the units. That's allowed. There's no and similarly, I can put on and off laser ons and offs in any order I would like. Right? No problem at all. Okay. Now, what happens if we were to go back to our original thing? Right? This validates, no problem. But remember, we had tried that thing with a group, and let's undo that group for just a second. Go back to our XSD file, and instead of a group, we're going to put the EX laser off. Let's do laser on first. Let's try that again. So now, when we run it, this event is legal because I said I could have 0 or more laser offs. But this is not, because it said I have to have all of my laser ons before my laser offs. And we could check this here real quick, right? By saying, okay, fine, let's follow the rules. Okay, no problem. Oh, the problem is here now, an on before an off, right? So this is the power of doing it in the group way, right? By saying, I want to repeat one of these things, a choice or something like that. So we'll go ahead and just put it back the way it was. Here's our group of laser stuff. And suddenly, problem goes away. Okay, so the last tool that we'll talk about for this section here is a fairly standard command line tool. It's open source. It's called xmllint. And xmllint is a very broad tool with a lot of features in it. But in this case, all we're going to do is use it to validate a schema, a file against the schema. Now, it's really simple. You can look at the man page. I've got it up here in Cygwin. Works the exact same way in a Linux distribution and stuff. But the program, right, is xmllint. And you'll get all these options, right? The option that we want is this one called schema, right? So we take a look at what that is, right? So if you cat this file, which was called example.xml, right? And this was the thing that I just made in Oxygen, right? We're going ahead and saved it. We got these things, okay? No problem. So if we run the thing with this schema option, it's very easy to use. We'll just give it our mysite.xsd thing, and then we'll give it the example file, example.xml, and voila. The important thing is it unfortunately it echoes back out a bunch of crap all the time, which you can turn off, and it says example.xml validates. So let's turn on another option, which I think is called no out, and the file was example.xml. And there it goes. It validates. I don't know why my screen is having trouble with the width or whatever, but who cares? So there it is, validating. Great. xmllint, neat tool. Let's make a change. Let's do one of our foolish ones, right? We'll turn off laser stuff, and we'll just do that quick thing to flop it around, right? That was an easy one. Okay. The element laser off, the schema is validity error, the element blah 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 laser off. This element is not expected. What's expected is a start time. Sorry, the font is a little, I suppose, squirrely with this. There. What was expected was a start time. Fails to validate, right? That's cool. This is something that you can use quite a bit to say, is this a good thing or not, right? And again, that no out thing is just, by default, I don't know why xmllint dumps out the contents of the file. It doesn't really do any inline commenting or anything like that. The error messages kind of come at the end. So why they decided to do that, who knows. But xmllint, very cool way of doing this. All right, so I hope you enjoyed this tutorial about XML schema definitions and how they can be used to make your stuff well. This was difficult to find a lot of this information, so this was part of a very large project that I'm currently working on at the university, and so there's a lot of tips and tricks that we had to find the sort of the hard way. But hopefully you had fun, or you learned some stuff. I had fun making it, and thanks.